Welcome to today's video on simple linear regression, a foundational concept in data mining. First, let's look at the outline for this session. We'll start by introducing the concept of simple linear regression and its mathematical model. Then, we'll explain the meaning and importance of the slope and intercept in the model. Next, we'll move on to calculating predictions and residuals to evaluate model performance. After that, we'll discuss the correlation coefficient to measure the strength and direction of the relationship. Finally, we'll demonstrate how to apply least squares regression using Python's scikit-learn library. This outline provides a clear roadmap to understanding simple linear regression and its practical applications. Simple linear regression models the relationship between an input feature, x, and an output feature, y, using a straight line. The equation y equals beta 0 plus beta 1 x defines the model, where beta 0 is the intercept and beta 1 is the slope. The intercept represents the predicted output when the input is 0, while the slope indicates the rate of change in the output for a 1-unit change in the input. Understanding these parameters is essential for interpreting the regression results effectively. The slope and intercept are crucial components of the regression model. The slope quantifies how much the output feature changes with a 1-unit increase in the input feature. For example, if the slope is 0.5, it means that for every 1-unit increase in the input, the output increases by 0.5 units. The intercept provides the baseline value of the output feature when the input feature is 0. Together, these parameters give a complete picture of the relationship between the input and output features. Predictions in a regression model are calculated using the equation y hat equals beta 0 plus beta 1 x. The residuals, defined as e equals y minus y hat, measure the difference between the observed and predicted values. Smaller residuals indicate a better fit of the model to the data. Evaluating residuals is a key step in assessing the accuracy of the regression model. The correlation coefficient measures the strength and direction of the linear relationship between the input and output features. Its value ranges from -1 to 1, with values close to 1 or -1 indicating a strong relationship. A positive coefficient means that the relationship is positive, while a negative coefficient indicates an inverse relationship. This metric helps quantify the linearity of the data. Least squares regression minimizes the sum of squared residuals to find the line of best fit. This method ensures that the model captures the underlying relationship as accurately as possible. The proportion of variance explained by the model, represented by r squared, measures how well the model fits the data. The higher the r squared value, the better the model explains the variability in the output feature. In the example code, we use Python's scikit-learn library to implement a simple linear regression model. The code demonstrates how to fit a regression model, make predictions, and retrieve the intercept and slope. This practical example shows how easily linear regression can be applied to real-world datasets using Python. To summarize, simple linear regression is a powerful tool for modeling relationships between two numerical features. The slope and intercept provide insights into the nature of the relationship, while the correlation coefficient measures its strength. Least squares regression ensures the best possible fit by minimizing residuals, and Python's scikit-learn library makes implementation straightforward. Understanding these concepts is crucial for data mining and predictive analysis. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.